recommended resolution for any aerial camera, because of distance away from target, is the maximum resolution, which is 640 by 512. And again, if I repeat, if we put that into perspective, that is actually only 0.3 of a megapixel. So resolution is limited straight off the bat when it comes to infrared anyway. So some of the smaller resolution cameras are not going to work for the sorts of application I'm talking about today. When I say continuity of insulation, heat loss, moisture ingress, they're not going to be able to pick up that. The image you can see in this on this slide, anywhere where you see red or yellow, even from this 20-meter height, is moisture ingress on a roof that is in need of repair. So again, if the survey is done properly at the right time, in the right conditions, with the right camera, then there's no argument as to what the heat is that we've found. In this particular case, it's moisture ingress. Camera sensitivity is also very important and varies quite a lot, where the minimum recommended sensitivity is what we call for 50 millikelvin, okay, which is 0.05 of a degree Celsius. That's important to understand. So that measurement, 50 millikelvin, is not a fixed number for every altitude or every distance away from target. That'll be from 1 meter away from target in a calibrated environment at 30 degrees. So if we have any other conditions other than those stated, the 0.05 of a degree Celsius will change. It will be less than that. So the further we go away from target, the minimum sensitivity of the camera will change, and it will get less. So by the time we're 30 meters away from target, we're not going to be able to see changes of 0.05 of a degree. We might be able to see 1 or 2 degree changes, maybe less. All cameras really are required to be what we call radiometric cameras. Okay, and what a radiometric camera is, in its most simplest form, is a camera that captures that radiation leaving a surface as a CSV file or Excel spreadsheet or a grid of numbers. Okay, once we have that grid of values, then all other changes can be applied in software afterwards. So we call that a radiometric camera. The radiometric part, as I say, means it's collecting temperatures, it's recording temperatures. If you choose a camera that is non-radiometric, you have no temperature data, and therefore the image cannot be changed, and it will be considered a camera that can look at captured data in full in color, but with no temperature data. And as I said before, the idea is to have a good telephoto lens, something that is as narrow, gives us as narrow as we possibly can go without compromising too much on field of view. And we settle on a 25-degree lens. Okay, the 25-degree lens is ideal. It seems that manufacturers want to give us the best of both worlds. A lot of the camera drones that are out there are not for or designed purposely for inspection work. They're designed for the search and rescue industry, which now in the search and rescue, this becomes less important. I wouldn't say unimportant, but less important to have a narrow lens, probably a bit more important to have a wider field of view. The problem with having a wider field of view is it effectively halves the distance we should be or can be away from target. So if you've got a 40-degree lens, for example, in the search and rescue world at 50 meters, you'll see twice the field of view than you would if you had 25 degree. Now, if you're in the inspection world, we lose half the radiation. So this image you can see here, we would then lose important radiation that could be moisture ingress by choosing a wider lens.